For the remainder of this chapter, we're going to look at measurement conversions. Okay, so I think we have four sections left. So we're going to look at length, weight, capacity, and then I'm honestly not sure what else, but I think there's four sections left. Okay, so for this section, we're going to look at length, and we're going to look at the US system of measurement and the metric system of measurement. Both we use both in the US, like the primary system of measurement would be the US or the English system, and then we also have some metric. And you're gonna, I would say people tend to like the metric system. It's usually a little bit easier to work with. Okay, so I have here in the United States, there are two commonly used systems of measurement, the US or English system and the metric system. We'll focus on measurements in both US and metric, specifically involving length. Okay, so for topic one, let's look at converting the US system units of length. Okay, so we have a couple of definitions. Okay, the first definition might be kind of new for you all, but it's new in the sense of what we're calling it, but it's an idea that you've worked with before. Let me word it that way. Okay. So we have something called a unit fraction, okay? So this is a fraction that has a value of one, but is made up of two different units of measure. Now, this idea has come up in a couple of things. Specifically, the one that I can think of right off the bat is dealing with fractions. When we're learning how to add and subtract fractions, we have to have what's called an LCD, okay? And so once we get what's called the LCD, we have to come up with equivalent forms of our fractions where the denominators change and become the LCD. So what we learn to do is we learn to multiply by this weird form of 1. So even though it doesn't look like a 1, it's essentially just multiplying our initial fraction by a value that equals 1. That's what a unit fraction is. So it's a unit fraction that is made up of two different types of measurement, so two different units of measure, but those units of measure represent the same amount. Okay? So essentially, when we use these unit fractions, we're really just multiplying by a weird form of 1. So we're not changing the value of what we're starting with. It's just giving us a way to convert from one thing to the next. Okay? And then the process that we use is called dimensional analysis. Okay? And so dimensional analysis is the process of multiplying a unit of measure by one or more unit fractions to convert to a different unit of measure. So if we're starting with feet and we want to convert to inches, we would start with the feet and multiply it by a unit fraction to convert that to inches. Okay. Now, common units of length in the US system are inches. Notice the abbreviation is IN period. Feet, the abbreviation is FT. Yards, the abbreviation is YD. And miles, the abbreviation is MI. And I do want to say that this idea of dimensional analysis, I forgot to specifically say it, but this idea of dimensional analysis, it is how we convert in the US system of measure. Okay. So example one, it says write two unit fractions that could be used to convert between the given units of measure. Now, at some point, if you have a class that meets face-to-face, your teacher will give you a conversion sheet. So it'll be a sheet with all of these different conversions that help us build these unit fractions. If you're in a fully online class, there is probably a conversion sheet given to you by your instructor somewhere in Moodle, okay? We do not expect you to memorize all of these. Okay, we expect you to learn how to use them, but don't put your brain power into memorizing every single one of these. Okay, so if you have a conversion sheet, get it out. If not, make sure you find one. Okay, so again, we're going to write two unit fractions that could be used to convert between the given units of measure. So we want to convert between feet and inches. And feet and inches, that's a pretty easy one. Most of us are familiar with feet and inches. So I know that 12 inches equals 1 foot. Okay, well, how do I create a unit fraction out of this piece of information? I know if I were to cut a piece of rope 12 inches long and then cut another piece of rope 1 foot long, they're the exact same length. So even though 12 inches looks really different than 1 foot, they represent the same amount. So if I wanted to create unit fractions, I could just put 12 inches over 1 foot. That is a fraction that equals 1. Okay, we have the exact same length divided by the exact same length. Okay, so that's one way we could do it, or we could have 1 foot over 12 inches. Now, I get that these look identical and they're very similar, but the numerator and denominator flip-flop, okay? And that's really important to understand that for each conversion that we have out there, there are two unit fractions we could use. And it's important because when we do this idea of dimensional analysis, we're canceling units. And in math, things cancel top versus bottom. So they cancel numerator versus denominator. So we have to be really mindful of which unit fraction we use when we start the actual converting. Okay? Now for part B, we have feet and miles. So I happen to know that there are 5,280 feet in exactly 1 mile. Okay, so how would I write unit fractions? Well, I could write 5,280 feet over 1 mile. These represent the exact same distance, so this technically equals 1. Or if I needed to, I could write 1 mile over 5,280 feet. Again, it equals 1, okay? And it just really depends on what you're converting from and what you're converting to, which of these you use, okay? So that is how you would write a unit fraction. All right, now for example 2, we want to do an actual conversion. So we're going to take this idea of unit fractions and we're going to do the actual converting. Okay, so for example 2, it says perform each conversion, include correct units with your final answer. I need to turn a light on. I'll turn a light on for the next video. I look creepy right now. Okay, so we have 19,800 feet. So what I want to do is I want to find a way to write 19,800 feet just as a fraction. And I do generally write it as a fraction. You could just leave it kind of hanging by itself. That's fine too. So we have 19,800 feet. And what I do is I usually just put it over 1. For me, I like to have numerators and denominators, okay? Now, I need to multiply this by a unit fraction that will get rid of feet, meaning the actual unit, FT, will cancel, and it'll leave a mile unit behind. And I want miles in the numerator. So whatever unit you're converting to needs to be the unit in the numerator. So I want to multiply this by a unit fraction that relates feet and miles in such a way that miles are in the numerator and feet are in the denominator. Okay, so that means 1 mile to 5,280 feet. Okay, and what happens here is the unit feet quite literally cancel and we're left with miles in the numerator. All right, so let's clean this up a little bit. If I were to just multiply across, I get 19,800, I get 19,800 times 1 mile. And then in the denominator, I get 1 times 5,280. And I have no other units, just miles in the numerator. So we want to write it like this. We want to show our side work, or we want to show our work, but we let the calculator do the side work. So we'll let the calculator divide 19,800 by 5,280. Do I have the calculator? Oh, there it is. So I've got 19,800. I need to divide that by 5,280, and we get 3.75. So let's see what that means. That means that 19,800 feet is equivalent to 3.75 miles. And there you have it, okay? So let's look at one more. We have to be a little bit careful with part B. We want to convert from miles to inches. And at this point, we know a way to convert feet to miles and we know a way to convert feet to inches, but we don't have a conversion that takes us from miles to inches. But that's okay because up here, when we were describing what dimensional analysis is, I said it's the process of multiplying a unit of measure by one or more unit fractions. So in this case, if you don't have a single conversion that takes you directly from one measurement to the next, you just multiply by a series of unit fractions, okay? So let's think about what this is going to look like. We have 4 miles over 1, okay? Now, I need to convert miles to inches, but I don't know a way to convert miles to inches. So far, I know there are 5,280 feet in 1 mile, and I know there are 12 inches in 1 foot, but that gives me 2 unit fractions that I can use. So for now, we know we can convert miles to feet, so let's do that. So I want to multiply by something that relates miles and feet, where miles are going to cancel out. And then I need to multiply again by something that relates inches and feet, where feet cancel out. So notice I have miles in the denominator of my first unit fraction, and then I have feet in the denominator of my second unit fraction. So let's fill in some really important numbers. There are 5,280 feet to 1 mile. There are 12 inches to 1 foot, and then let's see what cancels, okay? Miles and miles cancel. Those units quite literally cancel top to bottom. Feet and feet cancel. The only thing that doesn't cancel is the unit inches in the numerator, which is exactly what I want. Okay? So let's clean this up a little bit. My numerator, I have 4 times 5,280 times 12 inches. And then my denominator, I really just have a series of ones, which doesn't really do anything for us. So let's let the calculator now do our side work. And I promise I'll turn a light on after this video. So we have 4 times 5,280 times 12. Make sure you've written that down before I switch screens. So I had 4 times 5,200, whoops, 4 times 5,280 times 12. And that's going to give me 253,440. So 253,440. So we have 253,440 what? Well, inches. So if we had 4 miles, that is equivalent to 2,000 or 253,440 inches. Okay. So make sure you understand how to create unit fractions. Make sure you understand this general process of dimensional analysis. And the big thing with dimensional analysis is if you know how to create the unit fraction, you just need to know which unit goes where so that things cancel properly. Okay.